All right, this video is going to walk you through 8.2 individual quiz, both the Edge Elastic and the paper pencil part. Okay, question number 1 from Edge Elastic says, consider the roots of the polynomial functions below. Okay, so you're looking at the graph and you're trying to decide, are they real roots, imaginary, or both? Because this graph goes up, down, up, that's a cubic. I expect there to be, well, there are 3 roots. And I can see all 3, which means they are real. When I say I can see them all, I can see 3 spots where it hits the x-axis. That's how I know it's real. The second graph is a W, so down, up, down, up, down, up, down, up. That's a 4th degree, which means there are 4 total roots. I can only see 2 intersections, so that means there's 2 real, and then the other 2 to make the W or to make the 4 must be imaginary. This final graph is a parabola, okay? And so we know a parabola down up has 2 roots. That's an x squared graph. And clearly it never crosses the x-axis. That means both of the solutions are non-real or imaginary, okay? Question number 2 is asking us to multiply imaginary numbers, okay? So you could do it using the FOIL method. Some of you like to use the FOIL method, or some of you like to use one more page, the generic rectangle. So the question was 3 minus 4i times 2 plus I, okay? And there's no sign in between, so I know that I am multiplying. So I'm going to do 3 minus 4i times 2 plus I. Multiply it just as if they were x's. So 6, 3i, negative 8i, and negative 4i squared. Now, I know that the 6 goes here. Negative 8 plus 3 is negative 5i. And remember, when I see negative 4i squared, the I squared does something a little bit tricky. I squared just means negative 1. So this is really negative 4 times negative 1, or negative 4 times negative 1 is positive 4. So I really have 6 minus 5i plus 4. And of course, 6 and 4 are like terms. So I always want to write my imaginary or complex solution as the real part first, the imaginary part second. So 10 minus 5i is my final answer. Okay, question number 3 from Edge Elastic was 7i times 7i. Again, this is multiplication, and there's nothing being added or subtracted in the parentheses, so I don't need to use a generic rectangle. 7 times 7 is 49. I times I is I squared, and we just talked about I squared actually means negative 1. And 49i squared means 49 times I squared, so this is 49 times negative 1. Or negative 49 as my answer. Sorry, negative 49. Question number 4 is another multiplication, and it's 5 plus 3i times 5 minus 3i. Now, if you'll notice, these are exactly the same number, 5 in front, 3i in the back, with the difference only being the sign in the middle. Okay, and when that happens, that's called the complex conjugate. Okay, when the middle sign is the only one that's different, it's called a conjugate. So again, if I multiply 5 and 3i and 5 minus 3i, I get 25 minus 15i plus 15i minus 9i squared. Okay, the 15i and the negative 15i make a 0 pair. Those are actually gone. So I have 25 minus 9, I'm remembering that I squared really means times a negative 1. Okay, that's negative 9 times I squared. So negative 9 times negative 1 is plus 9, and 25 plus 9 is 34. Okay, question number 5. See if I have enough space. I think I do. Right here is 2 plus 5i, and then in between it has a minus 3 minus 6i. So it might look like a multiplication problem because of the parentheses, but remember when there's that minus in front of the second parenthesis, it just means to distribute a negative 1 or subtract all parts there. So I'm going to keep the 2 plus 5i alone. Negative 1 times 3 is minus 3. Negative 1 times negative 6i is plus 6i. Now this is just a matter of combining like terms. 2 minus 3 is negative 1. 5 plus 6 is positive 11i. Again, we always want it to be in real plus imaginary form, a plus bi form. Number 6 also had us adding, okay? So same idea, even easier than the subtraction. When there's a plus sign in between, don't try and multiply, just add the like terms, okay? The negative you have to distribute through. The positive, I can just combine like terms. 3 plus 6 is 9, and 4i plus 3i is 7i. So operations with i's are the same, adding, subtracting, multiplying. They're all the same as if it was with x's. The difference is anytime you get an I squared or an I to a higher power, you have to simplify it, okay? Question number 7. Question number 7 says, negative 1 plus I root 3 is a solution to the quadratic equation. It doesn't even matter what it is. What is the other solution? You're just simply going to write the complex conjugate. So you leave the negative 1 the same, and you change the sign in the middle. We've talked about when we're solving equations, imaginary solutions always come in pairs, a plus or a minus. And the plus or the minus only comes for the I part, okay? Finally, for edge elastic, question number 8 looked like this. F of x equals negative 4x times x plus 7 cubed times x plus minus 6 squared. And this was a select all that apply. So basically true or false for each of those 6 statements. First of all, the degree is 6. And that's true, okay? I see an x here. This x is cubed and this x is squared. So if I were to multiply all of the x's out, I would have a total of 6. Okay, x times x cubed times x squared is x to the 6th. Next, it has a negative orientation. Okay, well, if I look in front and there's a negative in front of the whole thing, then that tells me, in fact, yes, it does have a negative orientation. Okay, so this one is also true, again, simply because of that negative sign. Number 3, it has 6 different x-intercepts. Well, that one's not true. The intercepts are at 0, negative 7, and positive 6. So that one is not true. It passes through the origin, 0, 0. Couple ways you could attack this problem. One is you could put it in your calculator and check to see. I see I made a mistake. There we go. Check to see if it goes through 0, 0. Oh, that one's hard to see. Table. 0, 0. Okay, so it was really hard to see on my graph. Like I couldn't see that at all. It must be so steep. But if I look at my table, 0, 0, it's right there. Another way is if I plug in 0 for x, negative 4 times 0 times 0 plus 7 is 7 cubed. 0 minus 6 is negative 6 squared. But take a look. Negative 4 times 0 times anything, because of the 0, is going to be 0. So we know for sure, okay, that 0, 0 is a part of this graph, or that the graph does cross through the origin. Okay, and again, you can test a point, or you can look on the graph, either one. 7, 0 is one of the roots. That is not right. It's negative 7, 0, right? If I do x plus 7 equals 0 and solve for x, I get negative 7, not a positive 7. So that's incorrect. And then the y-intercept is 0, this crazy number. Well, we just said if we plug in a 0 for x, we're going to get out a 0 for y. So that is also not true. And again, you can look on your table for that. All right, let's tackle the paper pencil. And just like our last few quizzes, there's plenty of forms of this. So I'm trying to pick and choose from each form at least one question. If you have a specific question about your form, please ask me. Okay. Question number 1 says, solve the following equation, and it's a quadratic, meaning x squared is the highest power. And anytime there's a quadratic, you could first try to factor and use the zero product property, but for these, that's not going to work. You're going to have to use the quadratic formula, okay? So here's my quadratic formula. A is equal to 1, B is equal to positive 6, and C is equal to 13. So opposite of B, plus or minus the square root of B squared minus 4 times A times C. So 4 times 1 times 13, which is 52. All over 2 times 1, which is just 2. I have to do what's inside the square root first, and I get a negative 16. Okay, and remember, one of the big things in this chapter is what do we do when there's a negative inside the square root? Okay, and of course the negative makes it imaginary, and that we know that the square root of 16 is 4. So if I simplify this, I get negative 6 plus or minus 4i divided by 2. But again, I don't want to leave the answer in this form. I want to leave it in a plus bi form. And so I just divide negative 6 by 2, and I divide 4i by 2, right? 4 divided by 2 is 2. So those are my two solutions, negative 3 plus 2i, negative 3 minus 2i, to this equation, okay? It is okay to write it plus or minus, or it's okay to write it separately. It's not okay to leave it not in a plus bi form, okay? Question number 2 told you that x equals negative 1 plus 3i is a solution to an equation. Then it asks, well, what's the other solution? And that should have been super easy. You're just going to write down the complex conjugate. Still a negative 1, this time minus 3i. And then the second part of the equation said, take this solution and plug it into this equation to prove that it is a solution. So instead of x, I'm going to write negative 1 plus 3i squared plus 2 times, again, x is negative 1 plus 3i plus 10 equals 0. Well, in order to square it, we have to use that generic rectangle. Okay, negative 1 plus 3i. Again, this time we're squaring, so we've got to use the same thing on both sides. I'm going to get a positive 1, negative 3i, and a 9i squared. Remember, 9i squared really means 9 times negative 1, or negative 9. So 1 minus 9 is negative 8. And negative 3i minus 3i is negative 6i. Okay, so when I square this number, I get negative 8 minus 6i. Then I'm going to distribute the 2, negative 2 plus 6i plus 10 equals 0. Just copying the rest of it down. Okay, when I combine like terms, negative 8 minus 2 is negative 10. Negative 6i plus 6i, that's gone. That's a 0 pair. Plus 10 equals 0. Well, negative 10 plus 10 definitely equals 0, so I've shown algebraically that negative 1 plus 3i is a solution to this equation. Okay, finally, question number 3. Super important, question number 3. They tell you the solutions to an equation, and it's your job to write the equation. Okay, so we're going to work our way backwards. We're going to add 6 to both sides. I'm trying to get this I root 3 by itself. So I get x plus 6 equals plus or minus I root 3. Okay, so I just got this isolated or by itself. Now to make a quadratic, I want to square it. I also want to get rid of both the square root and the I if I can. So I'm squaring both sides. I probably didn't need the square or the parentheses until this step. Okay. On the left, when I square x plus 6 squared, please remember you've got to do x plus 6 and x plus 6. Okay, when you do that, you should get x squared plus 12x plus 36. That's just the left side. On the right side, I don't need a generic rectangle because there's no adding or subtracting in the middle. And remember, it doesn't matter if it's a positive squared or a negative squared, it's just going to be positive. So I root 3 times itself, okay? I times I is I squared. Square root of 3 times square root of 3 is the square root of 9. I squared is negative 1. Square root of 9 is 3. So this becomes negative 3. Okay, my last step is to flip or to add the 3 to both sides. So I can make this side equal to 0, so I can put in a y there. So my answer for this version of the test is y equals x squared plus 12, oops, x, that should not be a y, plus 39 is equal to y. Okay, hopefully that was helpful.